In this lesson, you will learn how to evaluate square roots. On the left side of the screen, I have the first 25 perfect squares. Most students have memorized up to 12 squared, but it will really help you if you memorize at least up to 25 squared. So when you're asked to evaluate a square root, you're looking for two numbers that multiply to the number underneath the square root symbol. So if I come down here to square root of 100, the square root of 100 is the same as the square root of 10 times 10. So since we have two number 10s, that's why the square root of 100 is equal to 10. So once again, most students know up to the square root of 144. But it will really help you if you memorize up to the square root of 625, so that when you see a number like 225 underneath the square root symbol, you'll know automatically that it's 15, and you won't have to go through the process of finding that it's 15. So for the first four problems, we want to find the square root of each number. And for 121, we know that 11 times 11 is equal to 121, so the answer is 11. 121 is a perfect square, and there are two numbers that multiply together to give us 121, and so the answer is 11. For number 2, 196, the two numbers that multiply to 196 are 14 and 14. So I'm doing this problem the same way. Just this negative in front means to include a negative in the answer, so the answer is just negative 14. For number 3, we have 3 times the square root of 16. And 16, two of the same numbers that multiplies to 16 are 4 and 4. So I just take the 3 that's already in front, multiply it by the number 4 so that I get 12. So for number 4, this symbol in front is read plus or minus. So we have plus or minus the square root of 900. So one way that we can do this is we can say that the square root of 900, if we were to find two perfect squares that multiply to 900, it would be 109. So when you split a number up underneath the square root symbol, they both have to be perfect squares, and the square root of 100 is 10 times 10. The square root of 9 is 3 times 3, so that the final answer is plus or minus 10 times 3, which is plus or minus 30. And that plus or minus just means that your answer could be a positive 30 or it could be a negative 30. Now this is not the only way we could have done this problem. The other way is the list above only goes up to 25 squared, and 25 squared is 625. If you'd like, you can just pick up with 26 squared, which is 676, and keep going until you get to 900. 27 squared is 729. 28 squared is 784. 29 squared is 841. And then 30 squared is 900. So if we have plus or minus the square root of 900, we can split this up as 30 and 30, and we get the same answer of plus or minus 30. Now sometimes we get to numbers underneath the square root symbol that aren't perfect squares. For example, number 5, we have the square root of 17. Now 17 happens to be prime, but the important thing here is that not that the number's prime, but that it's not a perfect square. So what I'm going to do is I'm going to find the two perfect squares that 17 is in between. And 4 squared is 16. 5 squared is 25. So from here, I'm going to make a number line. And 16 would be here. 25 would be here. Or the square root of 16 would be here. Square root of 25. The square root of 16 is 4.0. Square root of 25 is 5.0. And right here in the middle is 4.5. So if I look at the distance between 16 and 25, 25 minus 16 is equal to 9. And if I take 9 divided by 2, I get 4.5. And then starting from 16, I add 4.5 to get 20.5. So the square root of 20.5 is right in the middle. So what I do is I look at my number line and I figure out where I think So I take my number of the square root of 17 and I place it on my number line where I think it would be. And I think it would be very close to the square root of 16. So without a calculator, I would estimate this to be 4.1. So I'm going to say that the square root of 17 is approximately 4.1. And if you'd like to check, you can put this in the calculator, take 17 and hit the square root symbol, and you'll get several decimal places that follow. It will fill the screen, but if we're rounding to the nearest tenth, it will be 4.1. For number 6, we have negative square root of 115. So for right now, we're just going to look at the number 115, and we'll just be adding the negative symbol at the end. So I know that 10 squared is equal to 100, and 11 squared is equal to 121. So if I make a number line, and I put the square root of 100 at the beginning of the number line, and the square root of 121 at the end, square root of 100 is 10.0, square root of 121 is 11.0, and in the middle we have 10.5. And if I take the difference between 121 and 100, I get 21. I take 21 divided by 2, and I get 10.5. And then I add 10.5 to 100 to find what the middle number is, and that gives me 110.5. So the square root of 110.5 is in the middle. So I'm going to take the square root of 115, and I'm going to say that it's right about here. And I'm going to estimate this to be about 10.7. So the square root of 115 is approximately 10.7, but I had a negative in front, negative the square root of 115, which is approximately negative 10.7. So for square root of 20, we know that 4 squared is 16 and 5 squared is 25. So we're looking for the two perfect squares above and below 20. So I have the square root of 16 on the left, the square root of 25 on the right. The square root of 16 is 4.0. Square root of 25 is 5.0. 4.5 is in the middle. And if I take the difference between 16 and 25, and if I take the difference between 16 and 25, we get 9. 9 divided by 2 is 4.5. And then 16 plus 4.5 is 20.5. And this is how we get the square root in the middle. So if I were to estimate the square root of 20, I would estimate it to be right about here, very close to the 4.5. So I'm going to estimate this to be approximately 4.4. So if you put this in your calculator, it would give you 4.47, which would round it up to 4.5. So as long as we're in the area, if you had said 4.3, that would definitely be too low because that would mean you think it's right around here. So 4.4 is my answer rounded to the nearest tenth. For number 8, plus or minus the square root of 60. We know that 7 squared is 49, 8 squared is 64. So if I make a number line, we have the square root of 49 at one end, the square root of 64 at the other end. The square root of 49 is 7.0, square root of 64 is 8.0, and we have 7.5 in the middle. The difference between 49 and 64 is 15. I take 15 divided by 2, and I get 7.5. And then 49 plus 7.5 is 56.5. So when I estimate the square root of 60, I would place the square root of 60 right about here, right about halfway in between 56.5 and 64. So I would say this is the square root of 60, and I would estimate this to be about 7.7. So the square root of 60 is approximately 7.7, but then we have the plus or minus in front. So plus or minus the square root of 60 is approximately plus or minus 7.7. For the rest of the problems, we're asked to solve each equation. And when you have an equation that has an x squared, and you want to solve for x, you want to take the square root of both sides of the equation. So that when you do that, the left side of the equation, you're left with just an x. So we have x is equal to the square root of 576. So what would help is if you memorize the first 25 perfect squares, so that when you see a number like 576, you know that it's 24 times 24. So since the square root of 576 is 24, since we have an equation, we have to include a plus or minus in front. So x is equal to plus or minus the square root of 24, or just the number 24. So for the rest of the problems, we're asked to solve each equation. And when you're given an equation that has an x squared, to solve for x, we have to remove the square, and to do that, we take the square root of both sides because a square root is the opposite of a square. So by taking the square root of x squared, we're left with just x, and then we have the square root of 576. So this is where you'll find it really helpful to memorize the first 25 perfect squares so that you can quickly identify that 24 times 24 is 576. So x is equal to 24, but since this is an equation, we want to include plus or minus in front. For number 10, we have 3y squared equals 108. And what I first want to do is get the y squared by itself. Since the 3 is being multiplied, we divide both sides by 3 so that we get y squared is equal to 36. Now that we have y squared by itself, we take the square root of both sides because the square and a square root are opposites, and we're left with just a y equals the square root of 36. 36 is 6 times 6, but because this is an equation, we can't just say y equals 6, we want to say plus or minus 6. For number 11, we have x squared equals 130. So x squared is by itself. I take the square root of both sides, and I get x is equal to the square root of 130. Now the problem with 130 is that 130 is not a perfect square. But I know that it's in between the two perfect squares of 121 and 144. So I have to estimate this one. So I make a number line, and I have the square root of 121 on the left, the square root of 144 on the right. The square root of 121 is 11.0, 144 is 12.0, and then in the middle I have 11.5. So if we take the difference between 144 and 121, we get 23, and then 23 divided by 2 is 11.5. 121 plus 11.5 is 132.5. So we know that the square root of 132.5 is in the middle. So if we are trying to estimate the square root of 130, I would place it right about here and say that it's either about 11.3 or 11.4. So we have x is equal to plus or minus 11.4. So x is equal to plus or minus 11.4. Always include the plus or minus when you're solving an equation. For number 12, we have negative 6x squared equals negative 384. So I start by dividing both sides by negative 6 so that I get x squared is equal to 64. I take the square root of both sides and I get x is equal, the square root of 64 is 8, and I just include the plus or minus in front because we're solving an equation. So x is equal to plus or minus 8.